Hello everyone and welcome back to Technology Innovation Hub. So it's going to be the 21st session on that our architectural journey. Let me share the screen. In the last session, we just discussed the lock switches and checkpoint behavior. We did that hands-on. So up next, what we have is about log writer conditions. That is when log writer writes. So there are conditions altogether initially 4, but altogether it becomes 13. But before that, let me just explain another little bit of things that we have to aware with regards to log writer. Of course, now we are aware of this log writer SCN numbers and log writer and commits. That's okay. This is from the documentation, log writer and the commits. So still we didn't discuss that much on commits, but we are aware most of the things with regard to log writer now. But further, let's try to understand. And SCN numbers and all, we know the initial part is understood. You can go through, you can read it, no problem. But anyway, I have explained this stuff. Except this one, this is log writer and inaccessible files. What is this? Because now we are aware that log writer, it has current, the file that is in use at the moment known as the current file. So once the current file finishes, the log switch happens. So it has to start right to the next available file. Now, what it says, log writer and inaccessible files. So suddenly, due to some reason, if the next file in the sequence is not available, what will happen? So that is what it says here. Log writer writes synchronously to achieve mirrored group. I explain how the groups are working because log writer treats a whole group as a one file and it writes parallelly to all the members within the group. If a log file is inaccessible, that's what, then log writer continues writing to the other files in the group. Now that is in the grouping situation. It is clear because we learn about grouping, and in the group, let's say if there are 3 members, and if one member is not accessible, Oracle will write to the rest of the members. That's true because there are 2 members available. So that is the whole purpose of multiplexing. If one member becomes unavailable in the group, since rest of the 2 members are available, or at least one member is available in the group, log writer will continue to write. So availability is there. So that's what it says. And there will be alert file, there will be indication telling this file is not accessible. But it won't stop log writer functioning. It will keep on writing since it has another 2 members, because only one has been lost due to the disruption or something. But the rest of the files are available. So at least if log writer can have the access for one member in the group, it will continue to write. So that's what it says. Group writes the error log writer trace file. Yeah, there will be trace file. Before that, short information will be there in the lab file, and there will be a trace file. If all files in the group are not accessible, or if the group is unavailable because it has not been archived, then the log writer cannot continue to function. Now, this is something else they are telling. If all the file, because now, okay, let me just take that document back. It will help you to understand this one further. Yeah, so this is the document. And you can see now in this multiplex, this document I used earlier also in the previous session to explain. So this is multiplex. So what the documentation says, if this member becomes inaccessible for the group, since other 2 members are available, it will continue to write. Minimum requirement is at least 1 member, but in the alert file, there will be error message. So why we multiplex into log files? To avoid those failures, such failures, for the log writer to keep on functioning. Now, what the documentation says here, if all the members in the group are not accessible, so that means now log writer is writing to this group. So that's the current. Log writer is writing, and the status is the current. That's the current group, because currently whatever the group that log writer is writing in at the moment known as a current group. So what they are telling is, if all the members are become damaged or are become inaccessible, if all the members become inaccessible in the current group where log writer is writing at the moment, so then what it says, log writer cannot function. That's true. And further it says, is not being archived, logwriter cannot continue to function. So it will fail. That's true. Because that is a, very rare situation, because we have multiplex and we are multiplexing across the disk groups as well, across the different disks, and not a RAID. Now, RAID, we have controller card. No, even if the RAID, if we are depending on a single control card, even if we have multiple disk units in the RAID, if we are depending on single controller card, if the controller card fails, everything is all over. So that's why we are not considering RAID as a way of multiplexing. So multiplexing, in a sense, separate disk controllers should be there. Control unit should be a separate one, and a separate disk, physical disk should be there. If we multiplex in that way, it's a very rare case. All three controllers and all the physical disks are going at once. That's a very rare case. So, but if that happens, logwriter unable to function, because then it will fail. And the worst case is even that group is not archived. Even that group is not archived, because it is a current group. For archiving to trigger, lock switch has to happen. With the lock switch only, the archiving triggers. So when Oracle start writing the next available group, these things should be archived. So that is where the archive is starting off. But we haven't discussed about archive. Let's talk about that one later. But in this case, if this one fails, the whole group gone, that means it is not archived, and logwriter will immediately stop the function. It will stop functioning, and that will cause logwriter background process to fail. Logwriter stop functioning means what? This background process, logwriter background process, this fellow will fail. Then the condition triggers. What the condition? Failure of any of the critical background processes will cause instance to shut down. So that's what happens. If this fellow fails, if this background process fails, there's a critical failure for Oracle database instance. Immediately instance will go off. It will shut down. So that's what documentation says. But that is, we are talking about a standalone database situation. We are considering that environment as a basic availability environment, because we don't have standby and all, and maximum availability architecture is not implemented. So I'm talking about on-premise situation, not on a cloud situation. Cloud architectures are different. And in case of on-premise also, if you are depending on a single database environment, where we don't have the high availability, DR site is not there, standby sites are not configured, active data guard, those things are not there, even the clustering is not there. So I'm talking about a single database. In a single database, the best scenario what we can do to enable high availability is multiplexing. Multiplexing is grouping log files. And even if we have done that, if all group members are gone, we have done our best to prevent it in our single database environment. That's a very rare case. But the other factor is if we haven't multiplexed. Now, this can be a worst case scenario. Now, in this situation, if we depend on a single file without multiplexing, even if single, we have only one file now, so if the current log file goes, it all over, because it is not archived and we have multiplex also, we are dependent on a single file. So that is not recommended. But in this case, we have take precautions to multiplex. So this is recommended even for production. Actually, multiplexing is recommended across multiple disk units, physical disk units. So it's a robot system. It's fine. But we'll talk about enabling the server failure, site failure. How do we address those things later with standby and with active data guard, then with real application clusters. We'll talk those things later. For the time being, I hope you got the idea. Why I explain it to that level, because this documentation talks about this. So it's okay. Fine. So let's continue. The next thing is this commit of transactions. So here also there's a little bit of things to understand, because whenever the commit comes, it is related to log files. That is why I'm just taking through all of those things. You can do all your readings here. But what it says, a commit ends the current transition and makes the changes permanent. That's true, because in Oracle, it's finished the transition. All the logs should be released, transition is completed. What will happen after the commit? Logwriter updates the redo log file with those data. That's what's going to happen, because the commit is a one condition for logwriter to flush data from redo log buffer to redo log file. That's what. And they are talking about table 10.1, second transaction. Yeah, we can visit table 10.1 and see. They are talking about that save point and commit thing, just to understand the commit, how it works. And again, Okay, yeah, let's go to it. Yeah, so this is what it says. This is all about documentation, and there's a commit in the existing transaction. That's true. For the current session, it finished the transaction. So commit, no? And then we are setting a transaction name there, salary update. The statement begins a transaction and name is like that. So we are giving a transaction name here and it begins a transaction because it's just a statement begins a transaction with the name, and after that the transaction comes. This is the transaction, the update command. We are changing the salary for Banda to 7,000. Right? We are changing. It's a DMN command. Right? And then what's going to be, and we are creating a save point after Banda salary update. So it will be marked. That's a particular save point, and you can roll back to that point. This statement creates a save point name with this name, salary after Banda salary, and ending the changes in this transaction to be notified back to this point. Yeah, not ending, enabling the changes in this transaction. Yeah, you can come back to this point. You can roll back to this point. That is what the save point means. And then what's we're going to do again, statement updates to 12,000. Now for another person, there's another transaction happening, and that case is going for 12,000. Now this is in the same session, two transactions are happening. And now we need, there's another save point. After Greenies update, there's another save point. Earlier the Bandas update, there's a save point. Now after Greenies update also, there's another save point, enabling we can come back to that point as well. There are two save points. Now what's happening? Roll back to save point Banda original. Yeah, we are all the way going back to 7,000 by passing this. So this statement roll back the transition to T3, undoing the update greenies, because yeah, we are roll back in this one as well, and we are going back to the previous save point, original save point, this one. So that's what's going to happen there if we do that. That's what it says, enabling the changes to this transition. Yeah, this was undoing the update to greenish, yeah, at T4. That's true. Transition 4. This is undoing that because we are going passing this point to the previous point. And what is this further again? Now there's another change. For green is making 11,000, and we are rolling it back now. Without any save points, we are rolling it back. This updates the statement rollback the changes to cell update ending the transition. Yeah. Now what's going to happen? This is going to roll back to the original point. We initially mark the transition. We never issue a commit bypassing all of those things. Anyway, now we have rolled back to Bandas level. No. So now we need to go back to the first place, this place. Cell update. That rollback command will take you to here, rolling back the entire transition. That's what happens. Roll back. And again, there's another command. Again, we are update 2. We are naming the transition as cell update 2. And again, we are making 7,050 for Banda. And after that, greeny again 10,950 we are making. And now we are committing. So what's going to happen? The statement commit all the changes made to cell update 2 all the way up to cell update 2, because that will confirm this transaction done and this transaction done, both transaction name. So both the transaction happen under this name with this transaction name will get committed. So that's what will happen. This just to understand about how those things are working, transactions committing. And with this commit, what's going to happen? The redo log buffer will get flushed to the redo log file, and those data will be updated to redo log file. But still, it may or may not be available in the data files until the next checkpoint takes place. It may not synchronize with the data files. Not may, it will not synchronize. We can't say may there, but data may or may not be available in the data file, because DB writer, independent of the log writer, DB writer fires. We'll talk about the conditions. So because of the DB writer fires, now since this record has been committed and it becomes LRO record, most of the cases it becomes LRO because this is not in use for certain time, because it's committed, transaction is done. In the database buffer cache, when the record becomes LRO, it is eligible to get flushed to the relevant data files. So most of the cases, committed data will not be in the database buffer cache, it will be in the relevant data file. Log writer commit is an independent process. So log writer writes the data to the redo log file. So at the checkpoint, only these two get synchronized. So by this time, data file may have the record, but it has not received this commit message from redo log file because checkpoint is pending. So at the next checkpoint, immediately Oracle will sync up the log file and data file. It will take a look at the redo log file. It will identify this SCN, there's SCN, and it claims a commit. The transaction table indicates it's committed, and it will inform the particular data file, okay, this transaction is committed, and you may make it permanent, because in the data file also the relevant SCN number is there. It's a unique number, right? True. Yeah, using the SCN number, we can identify a unique transaction across the database. So anyway, let's talk about those in more detail. For the time being, I'm just explaining very briefly. Yeah, so transaction names and update. Yeah, so if you go back here, our previous explanation, so we came from this one, commit and transactions. The database generate SCN and commit. You can go to this in no issues, and they talk about this. If you there's another important thing to understand here. Oracle database perform commit screen out. Yeah, you can just go through it. No need to go line by line. And most of the things I have explained. Block clean out. That's true. And there's another one, because we can issue commit no wait. And this ITL, initial transaction locks. Yes, ITL. If you just if an ITL entry. So what is an ITL? Yeah, we can just do a search. It is a entry in the block, which is for to handle the locks. ITL, you can just say in Oracle, yeah. So this is what interested transaction list. That's what this is. As I explained, Oracle keeps a track of rows that are locked per a transaction in the storage area at the top of the each block, called ITL. So interested transaction list is list of records to keep the track of the lockings that is taking place within the block, because we know all the records are inside a block. Ultimately, we will understand the logical structure later on the upcoming explanations. Oracle has logical structure, physical structure. The logical structure comes up with, we know the smallest data transfer unit is the block. So collection of blocks will make up extent, collection of extents will make up a segment, collection of segments will make up a table space, and table space consists of one or more data files. So we'll talk about those in more detail later. So, but that's up to table space is a logical hierarchy. So the smallest unit in logical hierarchy is block. Now within the block, all these records are located. Maybe one or more record depending on the size of the record, because we can define the block sizes now. Let's say if the default block size is 8K, 8 kilobyte, but you can always define multiple blocks. So that's the default block size, and the OS block size also should support that one. Here what it says, per a block, Oracle maintains interested transaction list, which is keeping the track of the locked records within that particular block. So that's what it says. As it clearly says, the rows that are locked per transaction in the storage area at the top of the each data block, the header part of the block, it will maintain this list, because it's very important to understand what is the status of that particular block. We will understand a block architecture later, init trans, max trans, percentage use, percentage free. There are a lot of parameters to understand. We'll go through it more detail later, but for the time being, just get to know what is ITL, interested transaction list. Fine. Now, if we just go back to our explanation, so there's an important point here. I think most of you are aware of that. With commit, we can give commit no wait, commit wait. So likewise, and you all are familiar. I think it is here. Yeah, log writer write redo to online log synchronously. That's true. And the transaction to wait for the buffer redo this before returning the commit to the user. However, for lower transaction commit latency, application developers can specify the redo be written asynchronously, so that the transaction need not to wait for redo to be on the disk, return from the commit call. That's why if you type commit no wait, what's going to happen? Oracle doesn't worry about whether redo log has been updated with the committed data, because generally what's going to happen, the default situation, whenever the commit happens, synchronize. Synchronize means the data should be written to the redo log file, the current redo log file, and it should retrieve the acknowledgement. The session should retrieve the acknowledgement. The server process should receive the acknowledgement telling, okay, now committed data is being written to the disk. So that is a normal behavior. But if you say commit no wait, commit no wait, what will happen? Irrespective of the acknowledgement of that committed data, it will not wait till that acknowledgement on the this mechanism or for the log writer, because log writer, the server process should receive the acknowledgement telling, and okay, now data is committed 100%. If you say commit no wait, it will not wait. It will not wait, and it will return the control to the user telling commit complete. So that is what the difference between synchronized and asynchronized. So it will make the transactions to end faster, but there's on the other side, the weak point is it cannot guarantee recover in case of a failure, because we don't know. Now, before the data being written to the log file, because it doesn't wait for the acknowledgement. No. Now, user has received the message telling commit complete. So user thinks, yeah, his commit is done, but he should be aware that the command is given commit no wait, right? But let's say if the user is not aware of it, but I mean, maybe it is not visible for him. Internally, from the middle tier, it might be written from using commit no wait. So in such case, if a failure happens for the database, now he might lose the data because it is not fully updated to the redo log files, because a server process didn't receive that acknowledgement, but the user has been informed the message is the data is committed because of the commit no wait. Hope is clear. Fine, just read these things, or just for you to get an idea. This one either we can give at I mean command line commit no wait, but again there's a parameter like this. I think commit write. Yeah, this is the parameter. Commit write. Now this parameter is initra parameter. We can set it at database level. We have the options immediate, batch, wait, no wait. Now this is the option that we are setting at the command line. Commit no wait. Default is commit wait. But we can set it, there are options like immediate and batch mode, and we can set it to no wait. At database level also we can set it. If only immediate on batch is specified, this option, immediate, if only immediate or batch, either these options are enabled, is specified, but not wait or no wait, then wait mode is resumed. That's why. So either these two options are specified, but it is not given. These two options are not given, but then by default the wait is active. And if wait or no wait is specified, but not immediate or batch, then immediate mode is assumed. These are, I mean, mutually exclusive parameters. So either of them you can set. Anyway, just go through it. We will be doing more details about these things later, commit write and all. Now, these things are most of the cases important for the application level end users. But anyway, so as a DB also better to get an idea. And I'm in 19C documentation. Fine, hope you got that idea. Okay, now let's go to our, now if you want to see that parameter, we can just type, yeah, let's see, show parameter, the default value we can take, look, commit, so commit write, the value is not set, that means the default value is wait is the behavior, normal behavior. So we can see the default value, it is given here. Default value, this is how. If this parameter is not explicitly specified, which is our case, then database commit behavior defaults to writing commit records to the disk before the control return to this. So that's a commit wait. So that's the default behavior. Once the data is 100% successful return to the redo log file, only the return is controlled to the end user session. That's what the default behavior. Okay, so that's what even in my case, that is the default behavior. So it will wait, it will write synchronously. The redo log files will synchronize with the data coming from the redo log buffer after a commit. So that's the default behavior. Okay, let's go to our presentation, PPT. Let's this one, it is done, and let's go to the other session. Locator writes one portion of the buffer to the online redo log file, partly circular buffer. That's what we understood. Unlike the DB writer, which uses the scattered technique to write dirty buffers, Scattered means now DB writer, there's no particular order. No. LR buffers are there, least and least buffers are there. When there is no pre-buffer, there are multiple conditions. That's why it's scattered read, it's scattered writes. But log writer is a circular buffer. Now, DB writer is a LR, least and least algorithm. But log writer circular, it goes in order, right? Sequentially. In the following circumstances, log writer writes all redo entries that have been copied into the buffer since the last time it wrote. Fine. So what are the conditions? The conditions for log writer write. In the following circumstances, log writer writes all redo entries that have been copied into the buffer since the last time it wrote. So log writer is going to write to the redo log file all the data from the redo log buffer. That means plus in the redo log buffer. So what are the conditions? The first condition is a user commit that we learn now. So these are the conditions where it forces log writer to flush the entire redo log buffer from the memory to redo log file. First condition is commit. Understood. We know that. Second condition, an log switch occurs. An online redo log switch occurs. And third one, we know what is the log switch now. And 3 seconds have been passed since the last write. 3 seconds. Since the last log writer fire happens, 3 seconds has passed. So then it flushes. Another one, the redo log buffer is 1/3 full or contain 1 MB of buffered data. So let's say if my log buffer size is 6 MB, when 2 MB fills, it becomes eligible for log writer write data from redo log buffer or redo log file. Or 1 MB, either condition. That means if it is a 3 MB total size, when 1 MB is reached, yes, again it's writing. Or, I mean, these are entirely, even let's say you have only 2 MB, your log file, log buffer size is 2 MB. When it's reached 1 MB, again it writes. So those are conditions, and 1/3 full and 1 MB. Then other condition is DB writer must write modified buffers to disk. That's why before DB writer writes, log writer has to write. So that's what the case. So that means whenever DB writer fires, automatically causes log writer to fire. DB writer must write modified buffers to disk. These are the conditions. So that means now there are 9 conditions for DB writer. Okay. So here we have 4 conditions, except this one. So altogether for log writer to write, there are 13 conditions. That's what it means. Before DB writer writes, log writer write means what? Whatever the conditions for DB writer to fire becomes a condition for log writer. No, that's what. No. So let's say at incremental checkpoint, checkpoint DB writer fires. When there is no pre-buffer, DB writer fires. Okay. And so there are conditions like that for DB writer. Let's learn those things. And again, we have alter table space offline, and we talk about those things. So likewise, there are mainly 9 conditions for DB writer. Whenever one of those 9 conditions fires, that causes log writer to fire. Because before DB writer start writing, redo log has to be written from the redo log buffer to log file. So that's what. So therefore, 9 plus 4 becomes 13 condition for log writer to write. So that is how the log writer writes or emptying the log buffer from log to the log file, from redo log buffer to redo log file, current redo log file. Okay, so before DB writer, this is the explanation. Before DB writer can write a dirty buffer, the database must write to disk the redo records. That's what it says. That's what I explained. Before DB writer writes the dirty blocks to the relevant data files, redo log has to fire. Database must write to the disk the redo records associated with the changes to the buffer. This is known as write ahead protocol. Before DB writer writes, log writer has to fire. Write ahead protocol. There are reasons for this, because now there are changes happening to the buffer cache. No, there are changes happening. So those particular changes are directly updated to the redo log buffer as well. So when those changes are firing to the data file from the buffer cache, when those changes are flushing from the data buffer cache to the data file, so those particular changes should immediately be cleared from the redo log buffer to the redo log file. That is what happens. That's a write ahead protocol. Hope you got the theory, but anyway, we'll be explaining this one again. I'll be explaining again on the DB writer as well. So hope you understood. If DB writer discovers that some redo entries, some redo records have not been written, DB writer discovering that certain redo not written, but I am going to flush those into the data file because now is DB writer has reached the conditions for those changes. With those changes are there in redo as well. Now detecting, DB writer detecting, okay, in the redo it is going to remain. So what's going to happen? It signals logwriter write. Then immediately it says, hey, look, logwriter, I'm going to clean up these things to the relevant data file. You better write. So that's what. Before me, you have to go. That's what it says. Write logwriter to write those records to disk and waits for logwriter to complete before writing data to the disk. Data buffers to this. That's what it waits. DB writer waits. Please complete and tell me that you have written to the redo log file. Then I'll continue. That's what DB writer says. So this clears the previous one, previous explanation. I mentioned if there is a commit has happened, if there's a commit going to happen, so logwriter has to clear no. But those committed data has already become LRO records in the database buffer cache because it is not in use. So definitely this guarantees whatever the committed data which is available in the redo log file have been already flushed to the data file. So this is how the synchronization takes place. So that's why there is no issue, even though the commit directly doesn't cause DB writer to fire or write the data to the data files. Commit is not a direct condition, but indirectly those data already being written to the data files temporarily. That is how it goes, temporary. So at checkpoint, these become synchronized. That's what's going to happen. Fine. So okay, I'm going to stop here. Yeah, there is one more slide. No, I think yeah, we have 2 more slides. So let me do it in the next session. Otherwise, it's dragging for long. Okay, let me meet you in the next session with the redo log continuation. Okay, have a great time. Bye bye.